Hey, it's me, Brother Iqbal.
And Brother Afnan here.
So first, let me introduce you about the oxidation state. So, what is the oxidation state actually? So, the oxidation state refers to the degree of oxidation of an atom in a molecule. In other words, the oxidation state is the charge of an atom if all bonds formed were ionic bonds. So, the oxidation state shows the total number of electrons which have been removed from an element or added to an element to get to its present state. Each atom is assigned an oxidation state value based on the electronegativity and periodic table groups. So let's dive into the oxidation state for the main group element. So the oxidation state for the main group element is mostly can be determined by the element's number of electron balance. From the electron valence number, the number of electrons they tend to gain or lose electron to achieve noble gas configuration is their oxidation states. For example, the oxidation state of metal group 1 and group 2 are plus 1 and plus 2 respectively, while non-metals group like group 17 and 15 have the oxidation state -1 and -3 respectively. Group 14 has the oxidation state of plus 4 to -4. For better understanding, let's have a look to magnesium chloride. The magnesium chloride has a sum of charge 0, since we know that magnesium tends to donate its 2 electron valence. It has 2 plus oxidation state in the molecule. Chlorine tends to accept the 2 electrons from magnesium, so chlorine is accept the 2 electrons from magnesium because chlorine needs to accept only 1 electron. Mostly, main group elements have the same oxidation state among their group, but there are some exceptions that some elements have vary of oxidation states. For example, in hydrogen peroxide, hydrogen and oxygen has the oxidation state +1 and -1 respectively. Hydrogen peroxide, a neutral compound, has a sum of charge 0. Oxygen needs to balance the charge with -1 rather than its usual -2 oxidation state.
Unlike ions of most main group metals, monoatomic ions of the transition metals may have more than one stable charge, and in compounds they can have several higher oxidation states. This variability of oxidation state is because the atoms of transition elements can lose or share the electrons without lose much energy. Moving across period 4 of transition element, we can see of the oxidation state variables increase until manganese of group 7, which has the highest oxidation state variables. Manganese itself has 7 oxidation state variables. After manganese, the oxidation state variable trend decline. Later transition metals have a stronger attraction between protons and electrons. They require more energy to remove the electrons and remain in stable state.
Boom. Okay.
When these elements are in lower oxidation states, they can be found as simple ions. In their higher oxidation states, these elements are usually bonded covalently to electronegative elements like oxygen or fluorine, forming polyatomic ions such as bromate, vanadate, or permanganate. Other properties related with the stability of oxidation state is ion in higher oxidation state tend to make a good oxidizing agents, whereas elements in low oxidation states become reducing agents. Going across a period, the +2 ions start as strong reducing agents and increase in stability. Meanwhile, the +3 ions start at higher stability and become more oxidizing across the period. To compare both main group and transition metal, we can say that main group typically have only one oxidation state. Lithium, sodium, and potassium from group 1 has a constant oxidation state, which is +1 in whatever compound they form, like lithium hydroxide or sodium chloride. While transition metal has a wide variety of oxidation states. Manganese has oxidation state of +7 in potassium permanganate, +6 in potassium manganate, +4 in manganese dioxide, and so on, depending on what compounds they form.
In summary, most transition metals can form more than one stable oxidation state, while most main or group elements tend to have only one stable oxidation state. Transition metals ion can be converted between their different oxidation states by oxidizing or reducing